We are going to look at pollution. Plants suffer damage from pollution just like humans do. The difference is plants can't get up and move out of the way. When we deal with pollution, there's a lot of terminology that we have to understand. One of them is what we call a point source. A point source is a place that emits pollution that is fixed on the ground. You can work on that particular source. The other is a mobile source. In this case, you've got a truck here and it is billowing out smoke. It's putting out all sorts of pollutants. There are a lot of states that have gone out and dealt with this. This becomes a tremendous source of pollution, even though you may only have one truck that's doing this. If you look at the entire state of Florida, we've got some 15 million people in it. We've got some 45 million vehicles that are traveling around all the time. We've got a point source, we've got a mobile source. A point source is something that you can locate on a map. A mobile source, you can tell where they're going, but you can't locate the individual place on a map. Some of the other vocabulary we deal with as far as pollution goes. We have a primary pollutant. This is one that is released into the environment in the form that it acts on other things. That would include certain oxides of nonmetals that come down as a form of acid rain. It could be fly ash or some other material like that. If you had a railroad car that crashed and released chlorine gas into the atmosphere, we would call that a primary pollutant. We have secondary pollutants. These are ones that are reactive type materials where a material is released into the environment and it forms another material that becomes your pollutant. We have certain types of photochemical reactions that occur when we have different pollutants coming together in places like the atmosphere. Some of the secondary pollutants have photochemical reactions that occur in order to make them. We'll look at a few of these. Other words we talk about is chronic. Chronic means over a long period of time. If you have chronic pollution, it's over a long period of time. Remember, a lot of times we talk about problems being done by exposure. It can be a slow exposure or a low-level exposure over a long period of time. It can be a high-level exposure over a very short period of time. We would call an acute type exposure. When we look at pollution, we look at acid rain and acid precipitation. There are oxides of sulfur and oxides of nitrogen. The X means that we don't necessarily have the number on here. It could be SO2, it could be SO3, it could be NO to the half, NO, NO2. We've got a lot of different ones, so the X really means that that particular part of it is variable. These give us acid precipitation because these, when they get up into the higher atmosphere and they react with water, they will form things like sulfuric acid or nitric acid, which then come down and could affect the pH of the soil. This shows you a plantation of pine trees where the trees are dead due to acid precipitation. This can be remediated over long periods of time. We have smog. Smog is a combination of smoke, chemical fumes, and fog. Smog can be particularly deadly, especially when you've got people out there breathing this stuff in. It reacts with the mucosa inside of the lungs. It causes burning. That can be very problematic on people. Smog is a blend of solids and liquid aerosols in a free state. If you go out into a fog and you shine a flashlight into the fog, you will see that it's made up of lots of little particles, which are really the aerosol. If you add in on top of that solid material, all of that stuff gets pulled into your lungs. When it's in there, if it comes in contact with the mucosa, it's going to stick and it's going to stay. So smog becomes a very problematic. You have phytotoxic problems that are not necessarily from what you got there. Many times you get a blending of these materials. It becomes a secondary pollutant. We have things like ozone. Ozone is part of smog. Ozone gives us what is called a haze. The Great Smoky Mountains are not full of smoke. They're full of ozone, which is naturally released from the trees, and it stays in the atmosphere as it is there. You get the smog associated with it. We have PAN, peroxyacetyl nitrate. This occurs when you have certain chemicals getting into the atmosphere, certain types of nitrates, and they react with other organic chemicals that are in the atmosphere. They create some very potent chemicals that could be problematic. This shows you a picture of a place with smog. You can see the mountains in the background. You can see how the material is kind of trapped into this area. The wind is not blowing, so this material does not clear out. You can often find this in cities that have very tall buildings. We have many times what we call an inversion layer. Normally, temperature decreases as height increases. If you get an inversion layer that gets trapped in a position because you've got topographical things around the outside, what ends up happening is temperature starts to decrease, and with this inversion layer, temperature increases, then it starts to decrease again. You get a lot of mixing down at the bottom, but you get no mixing up at the top in the inversion layer, which means that things get trapped. If you look at Los Angeles, it has mountains around the outside of it. The wind normally blows gently in off of the coast. As the material is blowing in, it's got nowhere to go. Get this inversion layer that gets trapped by the high mountains. These are very important because it traps material down in the base. These are places in the United States where we have problems with atmospheric pollution. Notice in Florida, we have got several areas, but a lot of these, like Jacksonville and Tampa, are large industrial centers. Down in South Florida, we've got tremendous agricultural areas. These can also produce problems because of the size of the area. This shows you tissue burn that is due to atmospheric pollution. Gases enter in through the stomata, they react with the tissue, and they cause damage. We have acid rain. One of the interesting things about acid rain is the deposition is not always where it forms. You have oxides of sulfur and oxides of nitrogen being formed in the city. You have wind coming up, picking that material up, putting it into the upper level atmosphere where it reacts with water, and it comes down out in the farmland or in the neighboring city. If you look at it, it's not uncommon to have what is formed in Chicago may actually be deposited in Pittsburgh. What's formed in Pittsburgh may actually be deposited out towards Boston. You might ban something locally, but that might not affect your problem because what's coming in is actually coming in from somewhere else.